Hello, my lovely students. I hope all of you are doing so well. And in today's video, we're going to continue to go through the algebra pack. We stopped it the last time at page 10. So now we're going to continue from page 11. The first thing that we're going to have a look at over here is factorizing expressions. Like here, for example, the first one that we have, let me just open this here. Let's go. The first one that we have over here is 5a plus 5. How can we factorize this? Look at the numbers that we have first, then the variables. So first, look at the numbers. 5 and 5. Can we get a common factor between 5 and 5? What's the highest factor, the highest common factor that between 5 and 5? In other words, what is the highest number that I can divide 5 and 5 by? Oh, Mr. Both of them are the same. I can divide both of them by 5. Yes, I can divide 5 by 5, which is 1. And here is the same number, 5 by 5, which is also going to be 1. So the highest common factor, this is a lesson that you took in year 4, year 5, year 6, year 7. You took it every year. The highest common factor between 5 and 5, Mr., is just the same number. It is 5. So the highest common factor is 5. What about the variables? Do I have common variables between the two numbers here? I have here a, the variable here is a, the variable here is, I don't have a variable. So, Mr., I don't have a common variable. So it's only 5 outside the brackets, this way. Okay, Mr., I got the highest common factor between them in the whole expression. The highest common factor in the whole expression is only 5. Good. What are we supposed to do right now? What are we supposed to write inside the brackets? Inside the brackets, we're going to divide 5a by 5. What is 5a divided by 5? 5a divided by 5. We divide the numbers first, then the variables. I don't have variables, Mr. So 5 divided by 5 is 1. So 5a divided by 5 is 1a. 1a, of course, all of you know that we don't write the 1, so it's only a. Okay, done, Mr., with the first one. The next one is positive 5 divided by also the highest common factor that we got here. So positive 5 divided by 5 equals positive 1. That's it. So this is how we factorize the expressions, the algebraic expressions. 5a plus 5 is equal to 5 in brackets a plus 1. This is how we factorize. I'm going to give you another example right now. Let's look at the question. Which question we're going to look at right now? We're going to look at question, let's say, K. All right, question K here says 9b minus 18. Look at the numbers. What is the highest common factor between 9 and negative 18? The highest common factor is what? Someone might say, Mr., it's 3. And I would say, yes, 3. We can divide 9 and 18 by 3. Yes. But can we divide 9 and 18 by a bigger number? Okay, that's why we say highest common factor. Can we divide the 9 and the 18 by a bigger number? Yes, Mr. We can divide the 9 and the 18 by 9. Both of them divide by 9. Thank you. So we're going to put the 9 outside the brackets. What about the variables? Are there common variables here? No, we don't have common variables. So it's only 9 that is going to be a common factor. So the common factor here is only 9, the highest common factor. Now let's divide the same thing that we did over here when we divided 5a by 5, it gives us a, and when we divided 5 by 5, it gives us 1. We're going to do the same thing over here. 9b divided by 9 is going to be 1b, which is just b. Minus 18 divided by 9 is 2. That's it. So it's 9 and then brackets b minus 2. This is how we factorize the question K. Let's move now to the next question. Here it includes variables. We're going to have a look at, let's say, question T. And also we need to have a look at question, let's say, all right, question T for now here, and question I. All right, let's continue. Question T says 6pq minus 12p squared. Okay, no problem. We're going to look at that. Numbers. What is the common number? The highest common factor between 6 and 12. What's the number that I can, the highest number that I can divide 6 and 12 by? I can divide 6 and 12, both of them by. Someone might say, I can divide them by 2, mister. Yes, but is this the highest number that you can divide both of them by? No. Can you divide, mister? Someone else, another person might say, I can divide by 3. Yes, you can divide 6 by 3 and 12 by 3, but is this the highest number that you can divide both of them by? No, because I can hear someone else saying, mister, I can divide both of them by 6. Yes, and this is the highest number that I can divide both of them by. So the highest common factor between 6 and 12 is 6. Here, dividing 6 by 6 and 12 by, but mister, we're not done. We're not done. That would be a mistake if I left it just about like this, 6. Why? I got the highest common factor between 6 and 12. Yes. But as we agreed, I need first to look at the variables. PQ and P squared. Is there a common variable? Yes, there is a common variable. Where is it? Here I have P. Here I have also P. Hey, do I have also Q's? No. I don't have Q's. I have only P here. Good. So I'm going to take the P from here into the P from there. Then now, the highest common factor is the one with the least power. I have P to the power of 1, and I have P to the power of 2. Which one am I going to take as a factor? I'm going to take the one with the least power, which is P. Okay? So it is 6P. Good. Let's continue. The Q, do I have a Q there? No, I don't. So I cannot take it as a common factor. I took only the 6 between 6 and 12, and I took only P from P and P squared. Why, mister, did I take P squared and I took only P? Because I take the one with the least power, which is P to the power of 1. Okay, good. Now I took the highest common factor, 6P. What am I supposed to do next? We're supposed to divide. 6PQ, we need to divide it by 6P. Okay. 6 bye-bye with the 6. It is 1 bye-bye. P bye-bye with the P. What is going to be left? Only Q. Minus. Oh, mister, is it going to be negative? Yeah, because here it's negative 12P squared divided by positive 6P. It's negative divided by positive, which is going to be negative. Now, the number 12 divided by 6 is 2. P squared divided by P. Okay, in dividing, we subtract the powers. P squared divided by, you can write divided by this way or over as a fraction. P, in division, we subtracted the powers. This is to the power of 2. This is to the power of 1. So it's going to be P to the power of 1, which is just P. Again, we divided 12P squared by 6P. So it's going to be 2P. 12 divided by 6 is 2. P squared divided by P is just P. That's it. All right, question I. I have here negative 6A, negative 12. Mister, from the numbers, I need the highest common factor from the numbers. The numbers here I have negative 6, negative 12. Someone might say, oh, mister, it is 6. Okay, but you notice here both of them are negative. So I want to take negative with me. So it's negative 6. Negative 6 is the highest, the biggest common factor. So I say negative 2, not the highest. It will work, but it's not the highest. Someone might say negative 3. It will work, but not the highest. So the answer at the end is not going to be correct. Negative 6 here is the highest. Both of them are negative, so don't forget to take the negative sign with you. So negative 6 in brackets here. Oh, the variables, mister. Do we have a common variable? Don't forget this, guys. Don't forget this. Do we have common variables? No, we don't have common variables. I have here a, I don't have a variable here. So let's now divide. Negative 6a divided by negative 6 is going to be only a. Negative 12 divided by negative 6 is going to be positive 2. Negative divided by negative is positive. That's it. Okay. Let's erase all of this. And go down. Everything here is the same. Next lesson here is substitution. That is a piece of cake. Here it says V equals AH. Find V if A is, for example, here 5.7 and V and H is 3. All right, no problem. V equals, we know that H means A times H. So it's going to be 5.7 multiplied by, weird handwriting, mister. Oh my God, what is this? 7 times 3. So what is V going to be? V is going to be 5.7 times 3, which is going to be exactly, this is 15.2.1, is going to be 17.1. 17.1. How did you do it, mister? I did mentally. If I cannot do it mentally, we just do the normal multiplication. 5.7, you multiply by 3. Do the normal multiplication. Ignore the decimal point, 3 times 7, then 3 times 5. You're going to find at the end of that it's 171. Don't forget, of course, to add the numbers that you carry out. Here, 3 times 7 is 21. 1 carry of the 2. 3 times 5 is 15. Plus 2 is 17. And I have only 1 digit after the decimal, so 1 digit after the decimal. 17.1 is the answer. We do the same thing with the rest of the questions here in question number 1. Here, P equals 2L plus 2B, which means 2 times L plus 2 times B. So here I replace L and I put the number, I replace B and put the number exactly like what we've done here in the first question. Let's keep going. Same thing here, y equals mx, which means m times x. Then you add to it b. So here I need to put, instead of m, the value of m in each question. Instead of x, the value of x in each question. Instead of b, the value of b in each question. That's it. Same thing here, a equals half bh. Do you guys remember this? It's the area of a triangle. A equals half bh. Okay, so it's half times b times h. So I'm going to replace here, for example, b with 4, like this, half times 4. What is half times 4? It's the half of 4, which is 2. Then 2 times h, which is 3, is going to be equal to 6. So of course, you have to write down the steps. I'm just reminding you quickly of the substitution lesson. Same thing exactly over here, substitution, but I want to remind you of something here. Let's take this as an example. 5c squared minus 12. It means 5 times c squared. What is c? C is 4. So it's 5 times, what is c squared? It's 4 squared. 5 times 16 minus 12. 5 times 16 is what? Mister, oh, 1 second. C squared, Mister, means 4 squared. 4 squared is 8. I can hear someone saying that. 4 squared is 8. I will kill you if you say this again. 4 squared doesn't mean 4 times 2. 4 squared means 4 times 4, which is 16. So it's 5 times 16, then you minus from it 12, which is going to be equal to 80 minus 12, which is going to be 68. Okay, the same thing here, a cubed, which is 2 cubed. 2 cubed doesn't mean 6. 2 cubed is not 6. 2 cubed means 2 times 2 times 2, which is 8. Okay, let's continue. Same idea here exactly. Here, be careful. When the numbers are inside the brackets this way, I need to finish what's inside the brackets first. So I multiply 2 by x, which is 5, then minus from the answer 7. And the final answer, we're going to square it, which means I'm going to multiply by itself. The same thing here exactly with the square root. Oh, mister, I forgot the square root. Okay, let's do one of them. I don't want to do this. I want to do another question. I'm gonna imagine, I'm just imagining. It's not the real question, guys. So you're gonna do in the homework of that right question, the x is 5. Let's just imagine here that x equals, let's say 12. All right. So I'm gonna do a 21 minus 12 first. What is 21 minus 12? The square root of 21 minus 12 is gonna be 9. Oh, so what is the square root of 9? Square root. I forgot, yeah, mister, what the meaning of square root is. Well, square root of 9 means what's the number that you can multiply by itself to give you 9. The number that when you square gives you 9. Okay, the number that when I multiply by itself, it gives me 9 is 3. Exactly. So the square root of 9 is 3. That's the answer. Okay, good, perfect. Let's continue now, going into the next questions. Same idea exactly over here, substitution. Same idea also here, substitution. Everything here is the same. Here they just want you to find b if a is 1. So it's 1 plus 4, which is 5. Oh, mister, that is a baby question. Yes, exactly. That's a question for babies. I'm sure they're going to get the full mark in it. So here, a plus 4, if a is 2, b is going to be 2 plus 4 is 6. And so on. All right. The same thing with everything over here. Now, page 16. M times M times M. Please don't say, what's the answer? Can you say it loudly? M times M times M. Say it loudly. Come on, speak. I can hear some people saying 3M. And please, if someone is sitting next to you, please let them kill you for me. Please, come on. M times M times M is what? It's not 3M. Why, mister? Because M plus M plus M is 3M. Yes, but M times M times M, we're adding the powers here. This is to the power of 1, this is to the power of 1, this is to the power of 1. So M times M times M is M to the power of 3. It's M cubed. Here, L times L times L times, we're adding the powers. I'm not going to do it for you. Here, write each of the following in the expanded form. Expanded form here just means that we're going to take it to the other form over here. B squared is just B times B, and so on. You got it? Okay, so let's continue with the next questions. Here, find the value of each. If x is 2, that's substitution. We learned how to do it. Oh, mister, oh my God, x to the power of 7. If x is 2, that means 2 to the power of 7? Yes. What is 2 to the power of 7, everyone? Can you say it loudly? What is 2 to the power of 7? Oh my God, if you say 14, oh my God. 2 to the power of 7 doesn't mean 2 times 7. It's not 14. 2 to the power of 7 means 2 times 2 times 2 times 2 times 2 times 2 times 2. So 7 2's multiplied by each other. What's the answer going to be at the end? I have no idea. Do it yourself. All right, next. Here, if I have a number multiplied by a variable, 3 times a. Oh yeah, mister, that's 3a. That's a piece of cake. Exactly. 3 times a is 3a. But here it's not 3 times a. It's 3 times a times a times a. What is a times a times a? It is a. Don't say 3a. We're adding the powers of multiplication. So it's a cubed. So 3 times a cubed is just 3a cubed. You're going to do the same thing over here, multiplying the x's first by each other, then by 6. and so on with the rest of the questions. They want you to expand exactly the same thing that is here. You see how this is expanded here? This is expanded. They want you to do the same thing. So here is going to be 5 times x times x. Sorry guys, I'm using the mouse. That's why my handwriting is really terrible. All right, let's continue. Here, substitution, we did it in the previous pages. We're going to remove a and put 2, remove b and put 3, and remember that there are powers here. Let's continue. Simplify the following, writing your answer in index form. The same thing exactly, adding the powers, adding the powers. Oh, ho, ho, mister, here is division. Shall I add the powers? No, come on. What do we do here? X to the power of 7 divided by x to the power of 2. What do we do? Exactly. We're going to subtract the powers. So can you say the answer? X to the power of 7 divided by x to the power of 2 is? Yes, x to the power of 5. And so on with the rest of the questions. Questions 3, 4, and 5. Let's have a look at this. All right. Let's take question A here from the first set. A to the power of 2, all to the power of 3. How can we do them? Okay, here, mister, you did this in the first video, mister, the first part 1 of algebra revision. Yes. And we agreed that we're going to multiply the powers. So A to the power of 2 and all to the power of 3 is A to the power of 6. Exactly. Okay, and so on with the rest of the questions. All right, simplify the following. Here, what are we supposed to do? Oh, mister, we're going to multiply the numbers by each other first. Yes, correct. 3 times. Where is the number here? Come on, mister, there are no numbers. You're stuck. Oh, no, sorry. There is a number, but it is invisible. That number does not appear here. It is actually only 1. It is 1. That's why we don't write it. So it's 3 times 1, which is just 3. X to the power of 5 multiplied by x to the power of 4 is x to the power of 9. Yes. All right, so we're going to do the same thing with the rest of the questions. We take the x's together, the y's together. We're adding the powers. And if there are numbers, of course, we're going to do the numbers first together. All right, let's keep going. Division is the same thing. We're going to do division to the numbers first. So 12 divided by 6 first. M to the power of 4 divided by m to the power of 2. N to the power of 3 divided by n to the power of 2, and so on. All right. What about these questions here, Mr. Ahmed? A to the power of 2, b to the power of 3. Everything is to the power of 2. That is a piece of cake. I'm going to just imagine that a to the power of 2 is to the power of 2 again. What do we do? Do you remember how we answered this up there? When it was a to the power of 2 and all is to the power of 3, we multiplied the powers. We said it's a to the power of 6. Do you remember this? We're going to say the same thing exactly here, as if it's a to the power of 2, which is also to the power of 2 again. So it's going to be a to the power of 4. We multiply the powers. B to the power of 3 to the power of 2 is b to the power of 6. Here, x to the power of 5, y, and all is to the power of 3. X to the power of 5 to the power of 3 is x to the power of 15. Y to the power of 1, mister, to the power of 3. Multiply the powers is going to be y to the power of 3. The same thing exactly with the rest of the questions. Here you're going to multiply first, which is adding the powers, and then you divide, which is subtracting, get the powers after that. Same in question number Question D and question E, everything is the same. Here, when you have fractions, it's exactly the same way as if you're dividing here. You just go again first to multiply a to the power of 7 by a to the power of 7. Then you divide the answer by a to the power of 4. Don't forget that in multiplication, we add the powers. In division, we subtract the powers. Question 6, everything is just the same. Let's move to the next page. Simplify the following. Writing your answer in index form. Oh, mister, it's the same thing exactly. Exactly, yes. Even question 2, yes. Oh, that's the same page. Yeah, it's just repeated, sorry. So let's move here. Okay. Fractions and variables. Oh my God, mister, that looks so scary. No, 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 it is not. It is a piece of cake. You don't believe me? Let's do it. The denominators are the same, mister, so it stays the same. That's half of my answer. Then what do I do with the numerators? What's x plus x? 2x, that's it. Done. Done with the first question. You see, couldn't have been easier. Question B, the same way. I'm not going to answer it for you. C, the same way. D, E, F, G. All of them are the same, mister. Oh, no. Question H is not the same. Are the denominators here the same? No, the denominators are not the same. Here's 3, here's 4. What are we supposed to do? Make them the same. How can I make them the same? Look for a common denominator. A common denominator. So go to the biggest one over here, which is 4. Let's keep checking of the multiples of 4. 4, can the 3 become 4? No, I can't. 8, can the 3 become 8? No, it can't. 12, can the 3 become 12? Yes. So the new denominator is going to become 12. Oh, 1 second, mister. Can you please repeat this again? Well, actually, you can repeat this part of the video again since that you're watching me online, but I'm going to repeat it again also for you right now. Here, we said 3 and 4. They are not the same. So how are we going to solve this problem? We need to make the denominators the same. How can we do it? Go to the biggest denominator, which is here 4. Check the multiples of 4. The first multiple is 4. Do you know the multiples of 4? Like the table 4. 4, 8, 12, 16, 20. The times table of 4. So the first thing is 4. Can I make the 3 into 4? No. Next is 8. Can I make the 3 into 8? No. Next is 12. Can I make the 3 into 12? Yes. So the new denominator is going to be 12, 12. That's it, mister? Not really. Let's just check what happened here. What happened to the 3 to become 12? I multiplied it by 4, Mr. Ahmed. Yes. So multiply the numerator also by 4. It's y. So y times 4 is 4y. What about the second one? What happened to the 4 to become 12? I multiplied it by 3, mister. Then multiply the numerator here by 3. So 3 times y is 3y. That's it, Mr. Ahmed? Almost there. The denominators now are the same, so it's going to be 12. The same. 4y plus 3y is 7y. That is it. The answer is 7y over 12. So y over 3 plus y over 4 is 7y over 12. Let's keep going. You're going to do the same thing exactly here with the rest of the questions in question 1. Question 2. The same thing exactly, but instead of addition, it is now subtraction. But I want actually to do with you, let's say, question K. Here, Mr. One of the denominators become the same. 3 and 4 again. All right, so let's take J, because I want to change the denominator. Let's check J. All right, I wanted the denominators to be the same. It's 2 and 3. How can I make them the same? Let's check. 3. Can I make the 2 into 3? No. The next multiple, 6. Can I make the 26? Yes. So make it into 6. The new denominator is going to be 6. 6. What happened to the 2 to become 6? I multiplied it by 3, mister. So multiply a plus 1 also by 3. I multiply the denominator by 3, multiply the numerator by 3. It's a plus 1 times 3. Oh, do you remember this lesson, expanding brackets? Mr. But there was no brackets, mister. There weren't any brackets there. Yes, there weren't any brackets, but I need to multiply the 3 not only by a. I need to multiply it by a. I need to multiply it by positive 1. That's why I put them in brackets. You want to do it just directly right away? 3 times a is 3a. 3 times positive 1 is positive 3. And here is the first fraction. Let's just extend the line over here a little bit. Minus. What happened to the 3 to become 6? I multiplied it by 2, mister. Then multiply 2a by 2, it becomes 4a. Okay. I have no spaces, so I'm going to go up. Here, mister, you have the denominators the same. Exactly. So I'm going to keep the denominator the same. I'm just taking the answer up. Keep the denominator the same, 6 and 6. All right, next, it's 3a plus 3. And I need to subtract from them, so minus 4a. Okay. How can we do this? I'm going to do the variables with each other here. 3a minus 4a first. I cannot do 3a plus 3. Don't say it's 6a. I will kill you. 3a plus 3, it's not 6a. You cannot even touch them. 3a plus 3 stays the same. So 3a minus 4a, yes. Here is going to be negative a. Don't say it's a. It's negative a. So I'm sorry, guys. I'm taking the answer of this question everywhere. All right. So here I'm moving here. So a minus 4a, as if you're 3a minus 4a, as if you're saying what's 3 minus 4? 3 minus 4 is negative 1. So negative 1a, but we don't write the 1. Again, 3 minus 4 is negative 1. So negative 1a, but I don't write the 1. So it's negative a. Negative a plus 3. That's it. Over 6 stays the same. So going back to the original question, a plus 1 over 2 minus 2a over 3 is negative a plus 3 over 6. Sorry again for answering this question in different parts of the page. And so on with the rest of the questions. Here, everything is the same. All right, this page here is just asking you to write an expression. Write the sum of 2x plus 3y. Sum means what? Plus. So just add them up. Oh, mister, you cannot add x to y. Yes, you can. Just leave it to x. What's the answer going to be? Plus 3y. 2x plus 3y. Product, what's the meaning of product? Times. Average, what's the meaning of average? Add them all up. Then you divide by, how many are they? 1, 2, 3. Then you divide by 3. So it's adding the 3 of them up, then you divide by 3. Mister, why did we divide by 3? Because they are 3 numbers. And mister, if they were 4 numbers, we would have divided by 4? Yes. If they were 10 numbers, I'm going to add all the 10 numbers and then I divide them by 10? Yes, that's how we find the average. Okay? So we add all of them up, then divide by, how many are they? 1, 2, 3, then divide by 3. Okay? And so on parameter, we add all of them up, all of the sides up. Square, all the 4 sides are equal. If one is 8, then all are 8. So you need to find the parameter. The area of a square, it's the side divided by itself. Multiplied by itself, sorry. Side multiplied by itself. So s times s, side multiplied by itself. If the side is x, what is the answer going to be? X times x is what? And so on. Here is the same thing. Parameter, but they're giving you the diagram. They drew it already for you. So how can we find the parameter of this? Yes, we add the length of all the sides, not only 2x plus 5 plus x. No, I need the length. I need to add 2x, the length of this side, to the length of this side, to the length of this side, to the length of this side. And so on with the rest. All right. Let's keep going. The same thing exactly over here. Everything is the same. That's it. I can't really remember if you took this page or not, but we're going to stop here. Thank you so much, everyone, and see you tomorrow.